Hi friends, today we are going to learn a very important periodic property, that is ionization energy. So let us understand what is the ionization energy. Ionization energy means the amount of energy required to remove an electron from the free and isolated gaseous atom of an element. This is the definition. Let us try to understand what is the original meaning of this. Let me consider an atom. So we know that the electrons will be filled in the orbits of the atom. So this ionization energy tells us how much energy we need to put on the atom to remove an electron from the atom which is in the gaseous phase. This is what we come to know about from the definition. So let me give a simple analogy from where you can easily understand how this ionization energy really works. We are present in a class and the teacher is present. Right, this is the stage. The teacher is present over here and students are present in the rows. Teachers are present, teacher is present here and the students all are sitting here. Okay, now the teacher is teaching something. The first row students, let us call it as first row, second row, third row and fourth row, and let it be the fifth row. These are the students and this is the teacher. He is teaching some concept or something he is teaching. The teacher's concentration will be more on the student present in the first row. The concentration will be present in all the rows, but as the distance from the teacher to the students goes on increasing, the concentration goes on decreasing. How? See, this teacher can easily see what this student is doing. That he will be afraid. The teacher may scold him if he sees that and this side. If he talks with his colleague, if he talks with his classmate, teacher may shout at him, teacher may scold him. So what he will do? He will sit quietly, listening to the teacher, whether it's immaterial whether he is interested in the class or not. But he will sit quietly because he knows the teacher will scold him. The next row, he will also sit in the same manner, but he will be a little bit relaxed because he knows he is away from the teacher. And these students, remember, they will be shading this person. So these people, if they are sitting, imagine if the students are sitting here and the next students will be shielded by the first row students, right? And what these students are doing, the teacher may not see it properly. He will observe, but that will not be clear. So in the next row, the same thing happens. Now the shielding, what these students are doing, they are shielding the activities of next row children. The same things goes on, and this row students, they are completely back benchers, the last benchers. I have respect on them, so not like anything like that. But the thing is, these students will be too far from the teacher. So what they are doing, teacher can't see. And teacher what will do, if some bright students and very intelligent students are sitting, they will be asking the questions and whatever the concepts are being cleared, they will be doing that. So what happens, the teacher's concentration goes in the earlier benches, earlier rows, and the later rows will have less concentration of the teacher. And these are easily susceptible to get attracted to the other things. Like imagine if this is the window, if it is the door and here is the window. If somebody is passing here, what these people will do, what these students will do, they will peep outside the window. How? Why? Because they will be having, first of all, they will be having no interest. If they are having interest, then they will see the teacher. If they don't have any interest, if the class is boring, then they will peep outside, right? These people, if somebody is moving here, they will grab the attention of the students. But if if this person who is roaming outside the corridor of the class, of the college, he will grab the attention of all the students equal. But this student will be attracted to these distractions in a lesser proportion because teacher will scold. But when we go down the group, or we can say when we go away from teacher, the distraction rate goes on increasing because there is no one to see these students. So we can easily distract these people which are away from the teacher. Now I will consider this teacher as nucleus and these electrons, these students as electrons, and these benches as the orbits. Now imagine that if there are many shells, then the energy I need to put on this atom to remove this electron will be lesser as the orbit goes on increasing, because there will be shielding. See, for these two, if I want to remove this first, this is K, L, M and so on and so forth, N, O, P, Q, like that, orbits. If I want to remove electron of this orbit, it will take more energy for me because the nucleus will be directly attached to the electrons. We know that by Coulomb's force, F is directly proportional to the product of charges and inversely proportional to the square of the distance between them. Hence, if this is a positive charge, this is the electron is a negative charge. So these are the charges. The force between them will be very strong because the radius is very less. Radius is inversely proportional to force. So if the radius is less, the force will be more. Hence, the nucleus and the electron will be more tightly bonded to each other. As I go away from the nucleus, the bond or the force that the nucleus will exert on these electrons will be lesser. Hence, I can easily remove this electron from this orbit. So this is how the ionization energy goes on decreasing. So this is what all about the ionization energy, removal of the electron from the free and associated gaseous element of an atom. Let us see how the trends goes on in with respect to the ionization energy. The first one, across the period. What happens if I go across the period? Imagine, not imagine, this is the periodic table. If I go, we know there are 18 groups and 7 periods. If I go along the period, the electrons will be added to the same orbit. Hence, there will be more shielding. There will be a shielding, means electrons will be added to the same orbit. Hence, the charge will be more here. Hence, the force of the nucleus will be more. Hence, the atom is going to shrink away. The ionization energy is going to increase. If I go down the group, what will happen? If I go down the group, the electrons will be added to the new shell, right? If I take sodium, if I take potassium, it will be right 11 electrons. This will be 19. So this will be in the second period. When I come to the potassium, it comes to third period. Hence, there is a new shell begins there. Hence, the atomic size increases. Those electrons which are to be removed, or which the outermost electron, that will be away from the nucleus. Hence, I can easily remove that electron from the nucleus or from the atom, and thus down the group, the ionization energy decreases. Across the period, ionization energy increases. This is how the ionization energy works on. So we are talking about the trends now. There are some exceptions in the ionization energy. I told across the period there will be increase in the ionization energy, but there are some exceptions. Let us talk about that. We have, right, in the second period we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. See here, from lithium to beryllium, ionization energy is going to increase, right? Because beryllium is fully filled. Now, according to the normal assumption, the ionization energy should increase across the period. But if I take a graph like this, ionization energy with the atomic number, if it is beryllium, the normal trend, what we assume, it is going to be boron will be having more ionization energy rather than beryllium, but it doesn't happen like that. Boron will be having lesser ionization energy rather than the beryllium. How? Boron is having atomic number 5, so 1s2, 2s2, 2p1. Right, by hand rule. I'm going to draw the orbital diagram. So this is the single electron present in the p orbital. So tendency to remove this electron is more, because if I want to try to remove the electron from this beryllium atom, it is highly impossible, because it is already fully filled, it is stable. Why will it lose electron? It will not lose. Whereas when it comes to boron, it is having an unpaired electron in the p orbital. We know that any atom will try to get more stabilized than what it is in its ground state. So we know that two types of stability can be formed, either fully filled orbitals or half filled orbitals. Here I can't get, if it wants to get half filled stabilized, then it requires 2 electrons. If it loses 1 electron, it will get fully stabilized. Rather than absorbing 2 electrons, it will try to give the single electron from it. So its ionization energy. So it will be very easy to remove an electron from boron rather than beryllium. Hence, boron will be having lesser ionization energy. So carbon, it will be having 2p2. So rather than losing, it will try to acquire the electron. Why it will lose? So its ionization energy will be increasing, right? Nitrogen, when it comes to nitrogen, 2p3, it will be having 1 more electron. Now see here, it is totally half filled and it is most stable state. It will not try to gain electron, neither it will try to gain electron, neither it will try to lose electron. So it will be in the same state. Hence, the ionization energy increases. Nitrogen will be having more ionization energy, and it will not try to lose electrons, so ionization will be more. When it comes to oxygen, it will be 2p4. So it will try to lose 1 electron so that it can get half stabilized. So it will be less than nitrogen. Fluorine, then fluorine will be 2 electrons, 2p5, and then fluorine will be 2p5. So it will try to gain an electron, not lose. So it will be having more ionization energy. And when it comes to neon, it's 2p6. It will be highly stabilized. It will never ever try to lose an electron, so it will be more, it will be having more ionization energy. Hence, this is how there is discontinuity with respect to the increase in the ionization energy of these elements. We can observe in every period, we can observe the same properties that are undergoing here. So it will be up and down. It will not completely in a upward motion, but it will be up, down, up, down. This continues throughout the periodic table. Hope you enjoyed this session, and you would have learned that what really ionization energy mean and how it will have its effect on the stability of the atom, and what are the trends that we observe in ionization energy. Thank you.